Line 6. Character 11 expect point separator, but it's not. Oh, that'd be this one. Right. So it doesn't understand this. Print something. What is this? It's a function invocation. Wait, I think I handled this, don't I? Interesting. Oh, so the expression could be something more than this. Did I even say function invocation as part of it? If not, then how can we call the function before? Oh, we just call the. I see. We use the call it statement, but there's no. I see. We invoke the function. Invoke the function. It's an expression, so we need to do something more than that. Well, let's see where we should do that. Unary. Unary expression, atomic expression. Atomic expression could be unary. Literal. No, atomic cannot be simply just be unary. Because unary can add more in front. So let's say, what if I have plus and then another plus? Oh, because the other one is considered as atomic. Yes.
Do all the gods not have like a vision? Because when I checked their profile, it said gnosis.
I don't know. I have no idea.
Yeah! I don't like it. I don't like it.
So it's identifier with something else. Let's think about the logic here. Atomic. It's kind of like a postfix. But what is the postfix then? Postfix gotta be atomic and something else. Okay. So from top, multiple atomic, left associated, atomic multiple. This is atomic. It's not actually atomic, darn. It's more like more like what? Postfix. Cast. Unary. Yeah, more like a unary. Yeah, if it's unary, we should change it a little bit. You think unary is unary after like deeper, higher. We're handling function call. Function invocation expression. Identifier and expression list. Do you think this is more like what, like atomic? Yeah, kinda. I can say kinda. Function invocation expression. But what if in the future try to make some kind of like lambda and you create the body and then call it directly? Then it's no longer identifier. It would turn out to be something like expression. That's true. Worry about that later. You worry about that later. For now, we just consider it as atomic. But what if I call a function and I return the function and I call the function again? Don't worry about that for now. Don't worry about that for now. It's something beyond what we can think. Yeah, also this one. I don't handle it for now. So if we do this, we need to extend atomic and the function invocation expression. Positonic expression, function invocation. So if starts function invocation expression now reading and do this. That's right. Create a method. Also create a method. And this guy should go to this one too. Yeah, let's do.
I don't want to do any more tasks because I did that. You did your task with Daddy.
Wait, it's supposed to be identity. Distance identifier token. Yeah, that's right. So it's a function. Cool. And then how are you gonna pass the function? It would be identifier with the expression. Sure. Function invocation with the token. Pass identifier, pass expression. You understand everything. That's crazy. Why would children not make? I don't know. Sometimes it's with children, sometimes it's make. What's your consideration behind with children, with children, with children? That's funny. What about make? This is make. Okay, I made it a make. Call, that's what I made. This is what I made. Parameter, no, that's what I made. Return, that's what I made. Oh, maybe I should use with children. Okay, with the children. Okay, with the children. What? Come on. Okay. So everyone is happy. No, not static. Public void accept. What else do we need? F2, okay, I'll remember that. Expression list. So function invocation is supported. There's some other issue. Still error. Oh, that's a statement. Doesn't know it. Print separator. It is not a separator. Plus atomic. Function invocation. Expression node. Oh, expression list. Expression list. Plus expression list. So let's see. Expression list. Plus expression list. Where are you? If it starts with expression, starts expression, starts comparison. Okay, that's fine. I don't see that as a problem, but this one. Oh, the plus logic. Yeah, sure. Function call. I haven't finished it yet. Passadina. Atomic. Plus atomic. Unary function invocation. We not really did it right. Sorry, I can't just do it. Token. Hey, who is doing this? That one. Okay. Assert. Starts. Token. Function token. No. It's not function token because we're calling it directly. That's funny. I'll just say token. Now reading. And read it. That's a part that we skip. Now expect open. Where's the ID? Oh, I'm sorry. This is supposed to be the ID. Token is this, and post identifier, post node, identifier, plus identifier, and expect this, post node expression list, and expect pose, and return. Now you know what to return. Token. That's right. So by doing that again one more time, we should be able to pass further. Function invocation expression list 1 2 number. And what's going on? Why is still complying? Expression 2. Oh, is it a return with something? No, it's not. It's a line 2, character 13. 13. Oh, I should go to 14. So plus. This plus surprised open print. This is why it's still waiting for something different. Function parameter. Let's see. Where's the return? Oh, here. Return identifier A. Wait, it's not a function node. Why would you consider it's a function node? It's not. This is actually it's adding. So return statement node. Something wrong with this that we need to address. pause return. Good. Let's see. Now we get return, and then we pause expression. If it's start expression, we pause expression. So it does. So and now it goes here. Pause expression. We'll go to comparison. And comparison go to additive, and additive is a additive will do. If it's an add, then go on, read everything, multiplicative. So this part's supposed to handle it properly, but it's not. Let's see what's going on. Return, identify A, expression list B. No. That is weird. That feels something odd. It's definitely wrong. Okay, expression plus expression plus expression. Oh, plus expression list. I gotta be very careful. Do we return expression or expression list? Can expression list to turn out to be an expression? Do we support the comma separated expression list as the expression itself as C? I don't think we have that. Let's check the grammar. Do milestone 3. Do we? Oh, it's not complete. Darn. Probably have something else. Expression. Oh, expression start with all. So, yeah, we don't do that. If we don't do that, then we try to pause expression. We should be able to see whether it is comparison. So A plus B silly. I don't see that's a problem. Let's do it. Pause. Okay. Debug. What do we have here? Let's get in. Step over. Left. Okay. How come we come here? Pause program, pause read. Pause state. How come we got here? Oh yeah, it's there. Pause expression, comparison, additive, multiplicative, atomic. Oh, atomic. Plus atomic could be unary, and the unary will get into this. For some reason, did not really get into the unary. Oh, literal. Okay, that's the order thing. Darn, I found the bug. We should do this later, because literal go first. Yeah, the bug is here. Atomic could be this guy, but this guy has this guy included. So we pause the literal. Okay, gotta be very careful here. Oof. We could do it here or start a separate one, let's say. What's the proper way of doing it? Because this one is included. They cannot just say, hey, make a different branch. Because I can tell that you have to go path B instead of path A. It's not like that. It actually pauses this common part, which is the literal. Interesting. Alright, so let's just pause literal and assign it to the common part. Who is that one? Who is this guy? What do you return? It's a pause node, okay? Pause node. And this will be the literal. And what literal is? Literal could be a constant, could be id, could be integer boolean. So it has to be an identifier. So if it starts identifier, let's see. If it's the literal, well, it's tricky because yeah. Be very careful about this one. Post literal, post unary. We got here. Post literal. And if literal instance, if literal instance of literal do we have a literal node? Oh, identifier, sorry, identifier. The dog just distracted me. Identifier node. If it's part of this identifier node, and then we will go on try to see whether it's a function call or not. All right, that is different. So if it's on identifier, and starts functionification, peak one. No, it's not. It starts. No. How to say that? Because after this ID, if it's a function call, we will be able to see a parenthesis. So it will be now reading, right? Now reading is punctuated open parenthesis. That means we are handling a function call. So we will be expect expect this, and then pause expression list, and expected this, and return literal and expression list functionification. If it's not this case, it's the expression, we don't care about terminal. So else, if it's not this way, we just return literal. So if that's the case, we don't need to do anything but just put it here. Ding 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 dun 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 dun. And if that's the case, is anyone calling you? Starts function, invocation. No, atomic actually handle it. Atomic handle that because it will start literal, including this guy. So we don't really need it. Do this, and you're not needed. Pause. This doesn't go on. Alright, that looks right. So pause. You got return add main block. Right. So What about semantic analysis? Runtime, because something is not, function invocation node is not handled. Function invocation is not handled. Let's say it's supposed to be here. So first we change this one. Function invocation, that will be expression, which will, it's funny. Expression, it is expression, but no one is listing it there. Visit enter, that would be the function invocation node. No, type load. Why do you say that's type load? Who started doing this? Or maybe it's me. Don't do that. You just follow the bad example anyway. How about other parts? I hope you don't really copy. Yeah, this is why. Alright, since that's the reason, do we have any other type load somewhere? That looks right. Pause type node, that's fine. Type node, yeah, literally type node. And this is visit type node, that's okay. Alright, let's go back. So, since we have the enter, we need to leave. Now, function leave, parameter list, parameter node, blocks, expression list. Well, we have statement here, we have other stuff here. Overwrite, function invocation, overwrite, function leave. Alright, same story. Since we add this, we need to handle it. So that would be you. And operator with leave. This is expression. Yeah, it is expression. It's invocation. So let's say, should I go before, go after? This is part of this one. Okay, sure. If that's the case, I'll just do it right now. Here, overwrite. Visitor. No. Function invocator. When we call, what do we do here? Function invocator. That's an expression. And wait. It's kind of like you call. That's a call statement. It's very close. And actually, we should do that there too. So, function invocation. Let's see. Where is the call? Oh, don't we have that? Wait, what is this? I don't care. Call. Yeah, there's no call. Doesn't make any sense. Where are we? Semantic analysis. What do we do when we call a function? What do we do? Yeah. There should be some kind of like a call statement, isn't it? Stupid. Call statement. Call statement node pause generate. Oh, it's just generating code. So when you, oh, okay, I see. So for semantic, there's no problem. Not really. We still need to handle the type. Let's just try run it. Pause. Yeah, semantic. So the semantic is it right? We try to return something. This is integer, and this will return the integer, which is correct. And here we say we function invocation. We try to call it, and this was supposed to return an integer. And this is the expression listed node. 1, 2. Return. Okay, so this is wrong. Not really wrong, it's just something we need to do. So function invocation node is supposed to get a type, and that type is supposed to be this one. Okay, let's see how we're gonna do that. It should be semantic. Semantic visit function invoke. Okay, here. Is it enter or leave? Leave. Okay, so when we leave, we need to do something. Function identification. Yeah, we got the identifier node out. That's right. We get the binding. That's right. We got the signature. That's right. Now we get the parameter accept, and then we do this. So there is a check to see whether we accept this parameter. If it accepts, then we do it. Otherwise, we will report errors, which just makes sense. Yeah, I kind of agree with you. Even though this is cheating, I should come up with this idea myself. All right, let's see. Who's the first one? The first one is the ID, so that's correct. 0. You get ID, and then you get the binding. Yes, and the binding can get a signature. That's weird. So where do we put the type? Where do we put the type here? Oh, yeah. So type and signature are different. Where we say, hey, the type is actually a function type. Yeah, let's just say that way. You know what? Function signature. Do I have this? Oh my God. There is a function signature. Kind of work as, you know, you have type in and type out. So this is actually the type that I come up with, which is the function type. Why do I do the function type then? Yeah, why do I do the function type? Because function type is actually the signature. Ah. But the signature doesn't really have a size. Oh, that's a design problem. See, the function type has a size like how large it need to save it as we return type into parameter type. Get size. And the function signature, pretty much the same. Oh, shitty. Oh, all right. So result type is the last one. I don't know what is variant is. That's your design issue. Store parameter. Okay, return type is no accept. Sure, since you have this already, I'm not gonna make a crazy lot of change, but instead I will follow the pattern. Now create this thing. Binding, let's just create a third in binding so you can get it. Parameter types. Signature, children type. What the fuck is this? You get this guy from signature, and then you let this guy accept this, and it might not. What are you talking about? Do you know what you're talking about? This is weird. I know you're trying to verify something, right? So let's say we just don't do it right now because I don't worry about this. Yeah, that's a good hint though. And instead, not even this one. What do? I need type from a signature. And I'll assign this node set type to this type. That's how I know that you're returning something, right? Now, since you have the signature and this binding get to the signature, and you should tell me where the signature is. And field. So now we have a function signature. You better tell me where I can guess the signature. Okay, then because the signature is actually my function type, I should be able to know where the function type is created. Okay, it's here. And who are you doing? The symptom visit. Function definition will create a type and then add the binding to it. So now instead of adding the type to it, it's not adding binding to it. It's close, but not exactly the same. See? That's a bad design to differentiate the type with the signature. The signature is actually the type. Otherwise, you want to add the binding to the function, for example, the f, and you say, hey, add the binding, and this is my type. So how come f's type, from a function, and a type is an integer? Do you feel weird? That is a problem. But let's say now we don't do this anymore. Instead, I'm going to pass in the type from this guy. And then we add the binding to this ID. Do we have a set signature? See? Your interface sucks. This is crazy. This is horrible. The whole signature idea. Can I make the signature actually a type? So let's say it is a type. implement its interface. Then what methods I need to implement? There must be some. Okay, get size and info string. Ooh, interesting. It's not that hard. Size. It's just a function size. Oh, wait, we can't do this way because the interface still collide. So someplace we wanna store the return value. Somewhere we want to store the function pointer. So for function pointer, we actually need to know the size of the type. But for function return value, where we know it's a function, so we don't get the type. Oh, okay, that's okay. So for this case, the size is the function type. And let's say, what is your info string here? So you got a parameter. So you have return type, which is a type. You also have param types. Oh, it actually worked? Oh, crazy. I don't really know Java, so I'm surprised it actually works smooth. And return type. It's a result type. Fine. Result type. Okay. Does this one actually have a print? No, it doesn't. Okay, great. So now we make this one a type, a function signature. What? Function signature. Function signature. Good. All right, and for the place that we need to fix, let's see, where is the problem? Now, you want to get the signature. I don't really care. And this is a part I want to get a type, which is the function signature. Yeah, see, the naming should be changed. Because we know this is a function signature. Because the binding itself is a function. So from the context, we actually can assume that. And now, for the signature, we do have a result type, which is here. That is provided. And now we can set the type to this guy, to the node. Yeah, so for semantic, this function invocations type, it will be the return type. So that's okay. We just don't do the verification right now. Semantic, again, semantic, someone report error. Say something. You cannot cast the semantic signature, function signature, primitive, and function. Semantic signature, function signature, semantic analyzer, signature, function signature, semantic type, primitive, and name. What? Who's casting what? Get type. Wait a minute. I didn't quite understand it. I need more. Sure. Let me just stop and restore. Do 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 do. Why it's a primitive type? How come it's a primitive type? What is this binding? This binding is F, and its type is integer. What happened?
Sorry, I got jump scared. Me too.
What?
There was a guy there, and it was a monster. And he don't like fighting, and so I ran across the ocean because I didn't think he would come. And he jumped into the ocean, and he was like not drowning yet because he was kind of tall. And then he zoomed that sword and jumped before I could blink. He appeared right next to me, and I got so scared.
You stop talking, you're sick. Wear your mask.
And that's the way the world works.
Function invocation. Oh, okay. Who set the type to integer? Has to be function definition. Let's check the function definition. Do I pause function definition here? Oh yeah, function definition here. So, function definition is identifier is supposed to be holding okay. I'm not sure how this one is supposed to be created. Let's see. Oh. Signature of. So they can get a signature from a what? Object. It just, in this case, really? Visit operator, they got a signature from the operator. What about us? What can we do? We are a function calling thing. How can we get to the signature? We have the return type, parameter list. No, it's not working that way. Even if you look here, it's a type. Everything is listed here. Oh, disgusting! Why this interface made me sick? Seriously? I'm totally speechless. Oh my god. Maybe just because people don't really use that. So Like you see, return this. It's okay for manual process, but I'm so done. Oh my god. Oh my god. So we have to pass in something. I don't even know what I should pass here. Maybe I just pass some. I mean, it could be nothing. This is a function call. What can represent this function has to be inside the identifier. This identifier got a name. Yeah. And then what? Then all the parameters. So how can I get all the parameters here one by one? And then list them here. Are you kidding me? Stupid. No, you're not supposed to create a signature right now here, are you? Function definition. If you don't think about the globe, like function can be defined under function or lambda, then you could use that function name string as a global unique indicator. Sick. Are you trying to create a signature directly? Well, before you do that, let's see what they providing this guy. They got an array of function signature and has a hash map from object to what? Object to a lot of signatures? What is that? Object is a key, function signature. They create the function signature, get a key, get a hash, and they accept it. So they got all the types. What are the types here? And say if they accepted the types here, then return a signature. So we'll find the first match. Okay. And function null signature will be new function signature of object. Return null signature. Function signature of.
Since you're doing that, I would go back and I'll come back.
Put the signatures for operators in the following static block. So here one example to get you started for the functions. The signature for add, addition. For this work, you should static important. Sure, of course. Let's try it. Punctuator. What have I done? Oh, I see. What about these? What are these? I guess there would be some kind of like a static. I don't know. What is that? Static import? Is it static import?
No, it's when you're fighting.
Like that? But it's not listed here. Maybe it's not this one. It should be a T. Oh, you are damn crazy. Yeah, this is the thing I want to introduce. How can I do that? Oh, lovely. Do I have floating support right now? No, I don't, so don't worry about it. First, we used blah blah blah. The code require this and that. New signature. New signature. One example is start with the functions. This two works should sending port. Yeah. What do we do here? Where is this guy initialized? The static signature function key accept type acceptance signature. I got all the one and trying to find the signature here, so that's okay. Signature of this. Try to find the signature for key. Contain the signature for key. This guy is from that. You have to. Oh, I was wondering, like, where is it? Where is it? Wow, this is static field, so it belongs to this guy. So the moment you create something with a key and the signature, it registered in this one. That's why for the static you only see this. All right. So if you're gonna add more, you should provide add with other stuff. Okay. Then somewhere here you should block the stuff right now here. We don't really support these operators, do we? Punctuator. Do we support multiply? Subtract? Multiply? I don't think so. Yeah, worry about that later. Later. So there's a signature. And we used to be using this guy. So maybe, does he have that? Like a signature of? Static signature of a key. Yeah, there is a of. Signatures of. Oh, it returns signatures. So I just want one. I just need one. Which is accepting, return accepting. So accepting will return null if it doesn't match. but they need the key and the types. And here is the operator. Where are the types? Left and right. Child types array as list.
Did you get this boat thing? Did you unlock the boat?
If it's only one, that's one item. That's child as a list. Otherwise, there will be left to right and a return left and right. So here, does he have something like a signature? And as a list, child types. So this guy should be able to get a signature. And also here, I want to get a signature for myself. How am I able to do that? These guys are statically created. So they exist one instance in memory. But I don't want to create multiple of them. And the signature handles the type converting. It doesn't really care about your like which function exactly. It just cared about the signature types, which means like the thing is why this matters. Why do you want to pass in a which variant? Why that matter? Why this matter? Get variant. The one is calling you. The one cares about you. It might exist for some extension, but I just don't see like how this guy is used. Right. Strange. It's not used outside even. Why do you want to specify a variant? And for variant, they are one. Thank God. I don't even know what you're doing. Genius. Oh. Okay, so we don't care. That's why you can put anything here. Up to you. Who cares? Signature. And for this guy, when you create it, you need a key. Okay. Why do you need a key? Why do you need a key? It sounds like for different function, the signatures are different. Oh, if that's the case, then I can give you a key. If you like. I can always give you a key. So how this key is used? Well, if you give a signature or signatures, it will actually set them in. Okay. Okay. Do you feel weird? Kinda. Yeah. So if it doesn't have a signature, then it will not really try to get it. Doesn't feel right. Let's just continue and try to fix the bugs and see how far we can push it. Why this one can't play? Let's see, what is the problem? Syntax. Oh, here. Thank you for catching it. Right. And here, now we're going to make one. Signatures dot. Oh. Wait a minute. Wait a minute. You define a function. You have to add the signature somewhere. And if you add it into the signatures, they're gonna. Something very strange. Maybe the signature should not be shared anywhere, so we just create one. Make, build, create, make. And what do you want to do with it? Make a signature. What do we need? What do we need? We need the return type and the parameter types. So you just accept the types. And let's create that thing. Let's go there. So yeah, I hope you are smart enough to figure this out, because I don't know how to do it. So you pass in function accepted which variant and that type. Not exactly right. As I say, which variant? int variant 1. Now, figure it out. Type parameter, new type parameter, type size. For I type parameter I. What is the... No, where's my return type? Or result type? Thank you. Yeah, that looks right, even though it's super ugly. Ding, 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 ding. I don't want to change you right now. Let's just go on to the place. Semantic visits, signature. No, not you. Where are we? Oh, here. So now we create a signature. And this signature should be bind. and you set this type. Identifier dot get binding set signature. Set signature. So you already have signature? No, then why 2? The signature equals signature. And where are you? Signature is here. So this dot signature is nothing. And somewhere we will get the signature. Yeah, because you set signature. You set signature here. And later we're gonna get the signature. And also we can get that type.
Why are you using G, bro? Because that was the win.
Function definition type. Function definition type. ID has this type.
That's happening to you.
This node. How about now?
I got annoying. They keep hurting me and nothing.
Oh, this is function invocation. Oh, yeah. Thank you for catching the problem. I know this problem, but I just forgot. So now, apparently, this is no longer a signature. Instead, we want to know the function invocation type we can get from the signature, or we can, what this one is trying to do. This is the thing you want to do, and there goes the type because you want to get a signature from this type. I say, hey, you know what? You don't need to do that. The binding type can give it directly to you because you are now on the function invocation node, which is the ID node, which is the ID get binding. Yeah. So you get the binding directly. But someone was complaining that it gets, oh yeah, that's trying to convert the type to the signature. We don't need a signature right now. So actually no one needs the signature for some reason. Only when we print it, we need it. Lovely. Ugly. Alright, so now you see this function invocation actually get an integer type back. That's what we want. And where's the function definition? Yeah, function definition still have a function type, integer. Right. And it has a and b defined, which is here. Looks right. Yeah. So far, so good. Compile. All right. Base code is null. What are you trying to do?
It fell down. Quick, get it. Something fell down. You know when you're going to arrow. Yeah. Oh no, you got it.
Print. Oh, okay. Yeah, because it didn't really get to the address, and it's null, which is the code generating logic for the function call. So we should go to semantic. No, not semantic. Why am I going to semantic? We should go to the code generate logic. And then there would be visit, like a leave, visit leave function definition, visit block statement, statement declaration, expression,
Daddy said when the waterman comes, there's gonna be a water wing.
Should I overwrite? Is it something I need to overwrite? I don't think so. Or maybe I should. Yeah, I think it is overwrite. Public, void, visit, leave. Leave who? Leave. Function and vacation. Node. Okay. So function vacation node. What do we do? For the functional and vacation node, what do we do? That's expression. And we got the value. We call the function. Return the value. Okay, good. And why it's a void? Hold on, why it's a void? Function vacation should always return some value? Wow, that's tough. Because sometimes it doesn't really return some value. So how you deal with that? Or who knows that you are actually returning any value? Function and vacation. I'll just let it finish. So first of all, you get the function invocation. Have function and arguments. Function's supposed to be a value code? Wait, why do I think it's supposed to be an address code? Oh god, I'm crazy. Let's see, what about the call one? Call statement. So for the call statement, they just push the value and then remove the address. See, it is the address. What about convert it to remove address, remove value? How are you doing? Push D. No, that's not what I want. That's not what I want. Visit leave. No, nah, that's not what I want. Anyway, it's just function. Yeah, I might probably rely on it too much. I should actually think. So for this one, they probably should be an address. Because it's ID. ID, whenever you get it, always return the address. So for the function, maybe that's the same thing. It's where this guy is defined. Huh. Is function saved globally?
No, I don't know. What do you? Ah!
Yeah, I think so. It's in a global space.
Never mind.
So when you get it, you actually gets the
Show yourself.
address.
They already locked me.
That's where you can actually change the function pointer. So you want to convert it. So you can't just remove the value because it's not. It's actually an address. And for the arguments, it's all about a pushing to your stack. So you got this. Is it possible that we can generate the code for the expression list? No, because expression list could be used anywhere else, right? And like in the future, we want to support expression list to assign the value to somewhere else, and you have to evaluate one of them. And like every one of them, expression list. Wait, that's basically evaluate every list, every expression. Do we? No, that starts from operator node. You don't really handle expression list directly. Because when you visit expression list, you evaluate every one of them and then return the last one. So here's the difference. This expression list, now I see. So for the function call the expression list, the order they gotta evaluate it is not defined. And the meaning behind is different compared to the assignment, the one that used in the assignment. So here, if we set, hey, you run into the expression list and you just evaluated one of them, then they don't really do any push. Right. So for the argument here is the every one of them is a value which we evaluate here. We evaluate them and then we store them into the stack. This logic is for function only. Right, it's for function only. We need to use this logic to function invocation. So not just this, we should actually do this. So for function invocation, there will be two nodes. One is the ID, one is the expression list, and we got the identifier node function. That's one, and then two. And for every one of them, we push them into the stack. What's the evaluation order? We evaluate them from back to end. Wow. From the back to the first. This is a part not defined, but I think LLVM evaluate from left to right, and the others, GCC kind of like go backwards from right to left. And what we're doing is evaluate from right to left. I guess that's okay, because eventually I want to change this one to a C compiler, so that's fine. So We try to get all the value and push them to the stack. Call it store A, change. So that's a part we update the stack. Call function. And remove the function. And we call it. So after calling this, we hope the return value is function invocation supposed to put the return value somewhere. How are they supposed to put return value? They have to use the return statement, right? What if they don't? We have to check the. Well, then they basically just break the contract. So return value. And here's the thing. When we call the function, they come back with the return value. So it will be something like this, right? I don't know. Do they call and push the return instruction location? Return pop PC. They don't mention put the value on the stack. They didn't really say that they want to put the value on the stack. Who's supposed to put the value on the stack then? Oh, the invocation. Yes. So it has to be invocation. Put the return value on stack. Accumulator stack. Accumulator stack. From where? From mem stack point. So how about the value that I pushed in? Who's supposed to clean it up? Let's say they don't touch it. They just put the return value directly on the stack and we can fetch. So if they follow the agreement, then I should be able to grab it. Alright, so load this one. What do you want to use? You want to change the stack pointer? You don't need to change it right now, do you? You just need to load the value from the stack pointer. Stack pointer. I want to see what you want to do. Get type, subtract, store. So you update the stack.
Thanks for that, by the way. Oh no, another girl saw.
No, don't do this. This is silly. This is silly. This is not what I want you to do. You did the wrong thing actually. So now we get to the SP. Load from stack pointer. It's actually load I. I can put some comment here, do I? Yes. load return value. And then you worry about cleaning up the stack. Pulp documents. So you load the SP again. Return value is put over there, so be careful. And you want to push a value in, right? That's true. But what is that value? Function get type, get size. Okay. Function get type. What about the signature? Function is the ID. That ID. No. This function is ID, identifier node. And when it get type, it's a function. And it's not a function node, it's an ID. So when you associate it with the darn, sometimes I forgot the code that I wrote. So add binding, signature. Oh, so when I add the binding, I actually use the return type to the ID. So ID get type, that is actually that. It's just that the binding itself can get the binding itself can get a signature, which if you don't use it, you don't need to worry about it. So here for us, we got the function, which is the ID, we got type, which is return type, and we got a size, which is correct. And then, remember we actually pushed the value? We pushed a couple of values. That's this. So how large is that? Argument space. Argument sizes. Or size of arguments. Okay. You know that I want to accumulate it. Oh, so we know how many arguments that we pushed in. And if that's the case, then put them together and subtract them. And store this to stack. So SP get updated, V left. That's right, that's what we want. After calling the function, we clean up. We get the value, we clean up everything. But you have to make sure that they really put the value on the stack for you. That's tough, because maybe we didn't do that. Anyway, let's say function invocation. Did we generate code for function invocation? I know there will be a lot of problems on the way, but let's just try. Move on and see how far we can achieve. Let the code drive us. Wow, it actually generated code. Scary, isn't it? It's scary. Run. And compile and run. They got a 60. 46! Nice. That is wrong because someone messed it up. Alright, so now let's go back to the code generator. So this part is the one for the function call. The one that we just wrote. What? Function invocation. Yes, this is a function invocation. Remember, we have a call. They're so close. They are very close. Because most of parts supposed to be the same. So how can we do them right? A function invocation. A call is actually a function invocation code too. So after this, when we return, the return value is up there. There might be no return value. If there's no return value, then we don't need a pop. Otherwise, we pop. So this logic is interesting. It could be reused. Right. What goes wrong? Let's see. Call functionality. This guy. Now we got it. 2222220. Whoa. How many things we break? Oh, nested is not supposed to. 5. That's a lot of failure. And they're all related to the stack operation. All right. Congratulations. You have something to play with now. So we're expecting to be 1, 2, 1, 1, 2, 2, 1. And we would call F supposed to print 1, but it's not, it's print 2, which means someone did something wrong. And it's really hard to see. I mean, I don't know how to debug this. There's one thing we can do. Simplify it. So this will be simple function call with one argument. Oh, with no argument. Simple function call. Okay. So let's simplify it to this. And it's supposed to print 1 and 0, but it might not. Right, so let's just write an expectation too. 1, 0. And let's just call it simple function. Compile. Run. So they got 1. What? They got 1, 0. It's not wrong. You know what? So we should actually have different like 2. And for the first one, let's just keep it simple. Let's do 1 0 for this one. The result will be 1 2 0.好，非常好。现在我们知道有一个东西可以让我们 debug 了。那我们来看一下它生成了什么样的代码呢？为什么加了这个之后它就出错了？Oh, wait a minute. This part is wrong. The global didn't really increase, so whoever allocate that is not working. Let's try to initialize f. And this is supposed to be g, but somehow they're on the same address, so g actually override f. So when you call f, actually it called g. So why? Why they're on the same address? Who allocates the semantic? The global is 0. Oh, wait a minute, because the void might actually affect this guy, because we'll try to allocate space for this guy, and it's void, and the return address is used. That is the bug. So allocate, we try to binding for f, we need the signature now. Oh, damn it. In a binding, we need the signature. Type is type, signature is signature. Okay. So first, first the pass. We got a function definition. We're trying to add a binding to this ID, and it's here. You add the binding to the function. We need to think about this carefully. This is really something bad. I know this will kind of. I'm not saying it's gonna fix the problem, but you will see. So that's two function added. But the problem is, this will return a void function. Return void. Function doesn't really take any space. Function void. Let's run it. Compile and run. 1 2 0. Okay. What about this? Okay, for the recursion one. Node not defined for type. See, sometimes they actually require for. Yes. No. Maybe later. I am actually learning. You've been playing the game for the whole morning, afternoon actually. Because this is like, what time is it? And you're asking me to help you playing the game. And I'm not going mad, you know why? You know, I'm not going mad. Why?
Because you love me.
Because I always hope that you will go study when you think that is ready. So you can play, and it's almost 1 o'clock. I've been studying for more than 8 hours every day. 8 hours every day. And you probably learn for 8 minutes. Your life is your life. I try my best. No, I didn't try my best. I kind of hope that you will manage your life without being, like you said, you know, I don't want to do that anymore if you say that. So I don't say it.
Okay, I'm coming. We're all gonna do it.
You know you're playing game?
What?
You're playing games.
Who?
Right now you're playing games.
What play?
耍个游戏，把我时间耍废了。我已经浪费了几十年了，我不想再浪费了。耍游戏的时候你自己耍，不要找我。所以刚才，把它存的时候，因为绑定的时候我们要知道怎么分配东西给它，而这个地方，所以其实还是这个绑定出的问题，得想清楚到底我们要干嘛。我也不知，其实很难一次就看清楚，因为这东西边做边想的嘛，对吧？所以这个 signature 我们压根就没有用到过，所以在 get type 的时候，我们可能会 get 到别的东西，因为我刚刚 set type 绑定设的是那个 signature， 所以当我们在分配的时候，我们分配的东西是对的。那么什么时候我们在 get type 的时候，我们会要一个不一样的东西呢？所以出错的是 get type 的时候拿到了一个别的东西。哪些地方我会 get type 呢？这个地方有一个 function invocation 的时候，我们拿到了一个 function invocation 的时候，我们的节点类型。哦，对，这个地方其实应该是 get signature， 因为我们知道我们的这个 ID 肯定是一个这要小心一点。pipe type equals this assert type instance of functions signature， 然后 function signature 等于 type， 然后 set type 等于 signature 点 return result address。 So if we do this, then it might solve the problem. Oh, hope so. Okay, yeah, it solved this one. Let's go on, try how far it can go. Okay, I got here. Still have this problem. And this is recursion. What's wrong with the recursion one? Line 2, 10. OK， 我们在比较这个 n 的时候，看一下，先对它进行一个语义分析。语义分析，我们有一个比较操作符，在这个地方出了错 ，greater， 它拿错了，为什么呢？因为它处理不了这两个类型。但是刚刚已经说了，你是个 integer 嘛，对吧？所以 operator 为什么会在这儿出错呢？我们来看一下 operator node 在语义分析的阶段，语义分析 semantic analysis operator， 我们在拿它的时候，它是两个节点，所以先拿了 left， 再拿到 right， 然后 signature 去取东西。然后他报了一个错，所以错是报在这个地方的，否则的话报错，也就是在这个地方出的问题。signature 我们是这儿拿到的 function signature operand， 所以我们在这儿打断点，然后回到我们的 recursion，call recursion，yes。你在写字了吗？ Good, thank you so much. I love it. 比姐姐听话多了，真的。爸爸没时间管你们学习，你们要自己学，知道吧？好，谢谢你啊。I love you. Compile semantic. OK， 到这个地方不用管，接着往下走。Signature 来看一眼， 这个 signature. Yes, you need to practice. That's right. That's exactly right. 这个 operator 是大于号，然后我们去找它，然后给它的 child 两个类型都是 primitive 的 integer， 对吧？所以这个 signature 应该不会有问题，除非我们没有给它东西，然后它返回了一个 no， 往后走，然后直接进去，然后下一步，好，果然是 return null。为什么 return null 呢？因为这个里面现在只有 key 0 key 1 value function 前面有两个 function。哦，我大概明白了。greater 的话接受两个参数，这个做个什么比较 ？subtract。就做减法咯。我们跑哪儿来了？怎么又来这儿了？Function with parameter。好，现在是在这个上面挂的。然后说 load I assertion。在代码生成的阶段，代码生成阶段，咋也没报错呢？对啊，为什么这种会报错？哦，wait assertion compiling here。这个是 emulate 啊。是吧？ 为什么觉得有点诡异呢？
A B C D E F G H I J K L O F L. Wait, what? A B C D E F G H I J K L O F.
变异的手术手。Function with parameters.
A B C D E F G H I J K L O F. Papa,
A.
I get confused by the P. Is it supposed to be an M or O
L
here?
L M N O. L M.
I don't know what this is supposed to be.
L.
Supposed to be an M or
Yeah, supposed to be M.
this?
Supposed to be M. McDonald. Right.
Is it supposed to be the O is supposed to be an M?
Yes.
Okay.
Okay.
Yay! I did it!
Did I ever change this thing? Not really, right? So, what's wrong? Hey, SM code. Did I change anything? This is a function invocation. Right, I add this part. That's fine. That's okay. I don't see any unwanted change. Function signature. You don't need it. It's fine if you don't need it. Label. We don't use that. Don't worry about that. No exception of object can throw. Read. Catch. Value of word string. I didn't see this before. What's wrong? Instruction runtime. Static instruction reading exception. Public. Never get caught. I get caught here. Try So you're saying that this will never happen? What the? Wow. Seriously? Is that what you're talking about? Wait. I feel something is totally wrong. No exception with type object can be 30 and exception must be a subclass of throwable. Okay, sorry, I should not do that. Let's go back. So I don't want to make any change here, but you should tell me. All look good. Do you understand? There's something is off. This is irrelevant, but I'll just delete it anyway. Strange. How come you got all these errors? And where are they from? So confusing. I'll worry about that later. Just let me finish this first. So, this is a code generated. We have a F. We have 1, 2. Wait, what are these trying to do? Push the exchange and store the so change as stack. This part of the here. So first of all, we come here to initialize the FP and the SP. Right, and then we jump to main. We jump to main, and here we do the global pushing, so it gets the F. We push F into the global area, that's the function for F, and then push the load I, push I, so SP -4. Then store 2 there. Then -4. Store 1 there. Okay, so we're passing parameter to SP. Okay. And we push F, load I. Load I. And that's the address of the place that we save the F. So we load I, which we get to the location for F, and call V, which we actually jump into F. Jump to F. And here we do push I, load I, then we get SP, and load I again. Why do we load I again? What do we do here? SP. At first we get an SP. And right now SP points to the arguments, right? Okay. I see. Darn. Well, after we call V, we kind of hope that SP has the return value, even though we don't really do that right now. But we hope after this, the return value will be on the stack. But apparently it's not on a stack. Emulate. So 3, what the heck? 3 is there. Okay, 3 is on the stack. Who did it? Did I do that? I forgot. Did I? Jesus, did I do it? Anyway, 3 is there. So 3 is there. And then push the load I. This is a load SP. Basically just gets the SP value. So push the load I, we have the SP value. SP value right now is an address, and we load I again, which we gets the return value. Oh, after we call V, the value is supposed to be on the stack, not on the, on the frame stack, not the accumulator stack. I hate the design here right now. You know, you have 2 stack and people might easily get confused. But anyway, so you got the SP value, you load I. Here we will see the stack value. Which is this for SP. And you load the value out. Which should be the return value, if not mistaken. So that's not the return value, instead it's 46. So we should think about what does that mean for call this thing. So function call into it. That would be part of this. Semantic generate code for function invocation. Function invocation we call. And we return. So that return definitely means something. That's a function definition. Where do we define a function? Function definition. Okay, here. Okay, we gotta be very careful about this one. Right now we're on this file, ASM code generator, which is this one. The screen is too small. So we call this function, and it will actually have return. So what if it really say return? What does it do? If we run into return expression, you have a value. Do you allow people to actually return anything, because return can actually put any value on the stack or on the accumulator stack, and that might be dangerous because they might easily return statement say, hey, if I have anything, I put the value on the stack and just jump. But should I let you do this? Because you might easily break my contract. So when I do return, I better know that I'm actually in the function. So the node get function definition node will actually travel. Notice this, get class. If it's not, if it is, then do this. Otherwise, go to the parent. So we will go to the parent, try to find the function definition. If we can't find it, then that is wrong. So we'll try to get a function definition, go runtime exception. All right. So we're sure that this function is a function definition node, and we better know the type of the return stuff. So we get to the value. We got the value on the stack. How can we tell that is correct? You cannot, right? Can you? Oh, that's semantic chain. Semantic check. So we should do semantic check. Right now we're doing code generating, are we? Yeah, semantic check should do that. Like verify if you're doing a return. The type better match. Type check error. Say this node does not define for type, blah and blah. Type check error. Wait a minute. So when we pass the return, and we notice that it's actually inside. Oh, that's a wait, semantic? Not really, right? Because you have to really see this in a visitor. So that's a semantic, but it's not really type here. and you want to make sure the type matches. So this is the expression. What do you do here? That's a pause. That's a pause note expression. Right, and you know the expression type, do you? Return expression. You better have the expression type. Function get type. Function definition. Function definition. Node type. What is the function definition? Node type, get type. It's function definition in first pass. So the node get the type has the signature. My gosh. This is terrible. So this is a signature. And it doesn't really get result type, so I have to convert it as function signature. And then using this one to get the result type. I'll make sure the result type is the same, otherwise it does not match. But you don't really always have this guy, right? So you have to say if node.n children equals 1 and it's not the same, then do that. So with that kind of check, you can guarantee that you're all good, so you don't need to do this. Yeah, so you can assert. Wow. Now you generate code and you say, hey, I got this. I remove the code. The type is the same, so you know what to do with the type. You got the return address, and the expression is on a stack, and you're trying to return. It's on a stack. Do you want to put it in? Oh my God, that's tricky because I'm in the inside function. And I'm returning something matches you. So what if I return something, but your function actually saying return void? It would caught it. But what if I just return and with no value? Then you should do the default. We will handle that later. But at least for this return statement, you want to generate the code. You put the value on the stack, and it could be 1. Or 2, that depends. Right now, probably just 1, so we should be good. And there could be value, could be no value. Yeah, also just assume that the return value get put on the stack already, and we want to pull it out. That will be in the function call. So we go back to the function and we say, hey, after this guy, we probably have optional return value. If we do, then where is the value? So there could be a return value. And the epilogue, what we do is we put the RA back, put the return address. After we call someone, restore a return address, push to ASM. Oh yeah, return address. Did we save the return address? Dynamic return address. Oh yeah, we do have return address here. So the return address is stored. Return value. Return address. You get the return address from that part, but you probably need to store it somewhere temporarily. Wow. We need to save it. We need to save the return address. Otherwise, the return address will get and the FP. And you got a FP stored to the FP. So FP and FP go back. FP go back. Frame. We do everything. We move the SP down. Did we move SP down? Yes, scope size. Oh, wait a minute. Let me just read it through. First of all, dynamic link. Step 2. Return address. Dynamic link, return address. To the mem step. Step point to FP. It updates FP. Don't say this. It's confusing. Dynamic link. Return address. The SP and FP reserve space for dynamic and return address. and reserve space for this. Subtract block. Get scope. Allocate the space. Subtract. So we subtract this, and subtract this, and put the value back. And then you call the code. And you make the tag. And restore RA. So here's the tricky part. Imagine you put the return address back. The reason why do you want to do this, because you want to give that to return instruction. So I'm okay that you grab it first. So return address, you put it. You pull it from FP. And then you also pull the US. So that's the store. SP, FP. And you restore FP. This has to be in this order. So restore FP. You get FP minus 4. And then restore it to FP. So now FP is here. But your SP, look, this is a part. Before we call in this, we use the FP, we use the SP, we use everything, but after we are done, the FP is supposed to be our original place. And do we need any locals? No, we don't. So we should expect that after we calling everything, well, you probably will call other function, right? You call other function, you will push them into the stack, and you will change the SP, but you're not gonna change FP anyway. So when you're doing everything, you're gonna operate on SP, and this is actually another way as C#. You can reserve the place for parameter operation. So just reserve the maximum for any possible function call, and then start from there. You don't need to push pop. You basically just assign the value directly to that state. I kind of like that idea. It's just like if you do so, you cannot. If you do so, the better thing is that you don't need to push pop often while you're in this function. But the downside is that you cannot do periodic arguments, because you need to predict how many. Wait, you still need it. You still know, right? Because when you call any function, you know how many arguments you're going to pass there. Do you? Let's see. Well, yeah, I think so. Yeah, so you have that, so it doesn't really hurt. You can still reserve the common error for all the sub-function call. So if that's the case, you can reserve. But anyway, the SP is going to change. But after you finish, and here we're done with this function. If we're done with this function, do we care about the SP? Do we care about SP? No, right? So we should feel free to just set the SP directly to the FP. Then you don't need to worry about how you need to pop this, pop that. No, you don't. But the thing is, who's going to get rid of the... Oh yeah, let a caller clean up the SP for the parameter. So when we do this, we can probably... So now you get to the FP. Before you return FP, let's restore SP first. Yeah, let's restore SP first. So we get FP. What are you trying to do? City girl, what are you trying to do? I just want to get the FP and put it back to SP. Store I2. Runtime. Stat point. This is right, frame point directly to SP. Because I don't need to use it anymore. It's like the way we do here. Right, it's like, you know, we got SP, we store it to FP. Now we got FP, we store it to SP back. Very lovely. Nah, just use this. And after that, you can feel free to just restore FP, because SP now points to the first arc, not really first argument, the last argument on the stack. FP, restore FP. Right, feel free to do so. That's okay. And because you're going to change FP, -4. That's the one, right? I think it's correct. So after you do this, runtime, load, push, load, and store RAs again, the last one. So you don't need to save RA to anywhere else. If we really need to do that, we could do that. Like put it to the temporary error, but for now, it's okay, it's clean, it's there. And now we can return. But remember, we have a function. We have a value. We have a value here. That's the tricky part. That's why I say, hey, maybe we need to save RA somewhere, because you don't know how many space reserved for this return value on a stack. For us, it is just 1, but it could be complex value, whatever, or array. You need to have multiple items pushed there, so you can't just exchange. Whew, which might be tricky. But for us, let's be hacky. Do we know the function return? A function definition node, yes. So if function definition node, we're creating a function. Function definition. Function definition. After the function, okay, cool. So let's try to get to that type. This is a function. This is a function definition node. So we can get something out. Get type. And we know this is a wow, it can generate return. It can generate return? Maybe that's a good idea. Yeah. The node can probably handle that. But before we go further, let's convert this to this function signature. Node get type. function definition. Do we have a return v at all? Return with the value? Ah. It's like we have a value push there. So let's get the value out. No, not yet. The value should be put into. Should be put onto the stack. The value should be put onto the stack. Puts the value on the call stack. Yeah, all these are tricky because you gotta really appreciate the type. Just for now, we don't do that. Store I2. So it updates the SP. Load the SP, push shine, subtract, and push it back to SP. So SP now is lower. Now we can store the value to it. Right. Be careful. Be careful. We want to load to the value, which is SP value. So by doing this, you put the value to the... Okay. This is how you actually save the value over there. And this is the function call. So while you call this function, it will actually set the function definition. When you call the function, it will actually have the value in there. I know it's not complete, but let's see. Yeah, we have 3. So that's correct. Call recursion function. Oh, this one is dead. How about others? Let's get a general idea. To failure. Call function with parameter. This is the function with the parameter. What do you mean fail? Ah. Give it some expectation. The expectation will be 3. Why? For some reason they have compilation error. Does they have a different one than the one that I'm using? I need to check that later. Yeah. So after the function code generator, let's get close one. Because so many files are open. I just got so confused. Now, for the ESM code generator, we have function definition code, and then we have call statement. So call statement doesn't need to do that. Instead, because we have a call, so we can just say call statement. There are a lot of change, I think. How am I going to make this one here? So call identity, let's just change this one instead of identifier and expression, because identifier and expression is actually invocation, right? So there should be multiple of them. Function invocation expression, that's free. And function invocation expression. Do we actually have a function invocation node? Yes, we do. But we don't have a post logic accordingly. Yeah, it's kind of like this. It's a little bit duplicated. So let's see, call ID expression. Pass identifier. And then expect open, close, and just return. Identifier. So if we do this, then we deal with the call statement. Mia, you're really... Can you stop? Okay, so now for this one we have yeah, not finished. I can't just do that. This is function invocation call, but I still have a call, so that's different. So function invocation, that will be a post node. Function invocation, and we actually need to do is return call statement with children. That's a assert start call. Who's calling you? Yeah, good. And that would be a call token. Now reading token. Now reading. And we need to pass this call to this guy and make this one method, and this one will just do create a node and append a child and return node. So now since we have this semantic where's my function call? Oh, Jesus. call statement. Pass call statement will return call statement node with child. And when we do the code, we know call statement actually have a child, which is no longer expression list, but a function invocation node. Because it's function invocation, we don't need to do anything but code dot append remove. So what code is that? Function invocation code. Should be void, but it might have value on a stack, right? But do you know? Do you know anything about it? Function invocation stack. Anything about the stack? Yes, you do. You should. You probably should. We need to know the type, the function. So function invocation better have some get type. Function invocation, does it have any type? No, it doesn't. I don't think we do anything about it. Let's say with children we created. When we pass it, we didn't do anything. Yep, we don't. Function invocation has less information directly. We should work on it. So function invocation node has two nodes. One is the append. Call statement. Call statement has only one item or two. Call I expression. No, that's wrong. Where is this one? We don't have this one anymore. That's confusing. So with child, we only append one child. That's the function invocation. So only one child. That's 0, which is the function invocation. And function invocation has two child. One is ID. So we at least can get the ID out. It's not you. That's the ID. Identify. And for this function, you can get to the binding or get to the type. I don't think you have that directly. for the ID. Function definition, the ID, and binding. Did the ID get any type? So now you can get the function signature out. And if your signature is not void, then you add the pop. That's right. That's pretty much what I want. Ooh. Happy. Oh, yeah. Syntax error. Line 6. Call someone. Okay. Function invocation, so that would be pause logic or semantic logic. Well, it's a syntax error. Syntax error apparently is the parser. Parser pass the call. Token assert that. Oh, expect the call. Right. Again. Shouldn't just pass expression. Oh, pass expression list. That's actually one expression. So okay, I see. Statement. That's a statement. You have to terminate it. Statement. Whew. Would call function invocation. F. Oh. Return statement. Return statement could what is this? Oh, yeah. Append child with child expression node, pass node expression. Return an expression. Return could return expression. So that's optional. It might not really have it. So that's why there's a problem back then. Here. Because we try to return and the expression might not exist. Yeah, let's split it. If this, then we got that. If type doesn't match, then we report it. Else, oh, else is like the function you say return, but actually the function needs some value, but you don't offer, then it's still that's still wrong. Yeah, your logic is solid, kind of right. Stop. Expression, return expression. That's just one. Oh, I don't know this, but just go to some function. Compile. Run. Yeah, that looks right. Any other one? This one, call function. Compile and run. That's wrong. But this one. Same. So there's still some code. Bug. Did I change too much? Why there are so many bugs? And the test framework is not really working perfect. Let's see. Find a simple one and see what's going on. I don't need that many tests. I just need a simple one. Start from a simple one, a simple function call. This one. Compile and run. Okay, good. Problems. What this one is doing is try to call the function f, but somehow a report on line 110. here, load I. And what this load I is trying to do is oh, that's the SP. They try to get the SP, but right now SP is the end. So SP has never been really used. Why? Question is why? SP actually set to this part. memtop exchange pb exchange store I. So this is the SP. This is a part we do for SP. If I do p stack, you can tell. Right. So SP is this value saved here. That's actually correct. And they jump to main here, and we save F. And we try to call F. Wow, simple call, right? There's no parameter passing anyway. No, there's no parameter. We just want to call V. So let's see, p stack before calling F. That's 41. So 41 is the F function pointer. I try to call it, and yes, we get into it, and we return 111, which is this one. So after we're calling, after the call, p stack, after calling F. It's empty. After calling F, it's empty. That is actually correct because we didn't really save anything, put any value, so it's void. If that's the case, then we go on.
I'm wearing your shoes.
What this one is trying to do. What this one is trying to do. I'm going to send code to generate for a function. We try to get the return value. So FP is supposed to frame point, stack point, load point, frame pointer. Yes, frame pointer. After you call the function, you set up the frame pointer, and before you return, you put it back. So that's normal. Right now, you want to read it from the frame pointer. That's the correct one. And you want to load it. But somehow it's down 5,000. Wait. Hold on. I'm old. I can't just figure it out directly, immediately. So let's say we try to read the push D here. That's the stack point. It's supposed to get the 0 here. Right, so we should get to 0 here. Wait, frame point first? Oh yeah, so that's 4, that's okay. And then load it. So P stack get SP. So that's supposed to be the SP value, which is stack point. SP. Load return value. There is no return value. God. Function invocation. We invoke a function. When we invoke a function, do we supposed to put the value in the stack? Return value. Do we? If we do that, then we can pop from the call. Okay, so for the call, it will pop it out. But for us, we need to make sure that we put the value there. So the return value on the accumulator return value. How do you know that the value actually returned? So when you call V, there might be a return value, it might not be a return value. How can you tell? You get from the function. Function invocation, and a call. Where's the call? I need this part. I need to know, because you're a function invocation, so you're supposed to know the function, which is here. I have the function already. So that function is supposed to have a signature. And the signature is supposed to have if it's not void. Yeah, if it's not void, then it definitely have some value. Then put the value on the accumulator stack. So only do it in this situation. Found. Okay, so it did not really build. Simple function. Keep it. Compile. There will be a problem. Okay, function with the parameters. What's wrong with you? That's 3. That's correct. Hmm? Oh, Java assert. So maybe I did not enable assert. Oh. Oh yeah. Maybe that's why. But it would be weird though. Mm-mm. Oh, no. Ew. Oh, code is void. We try to remove print function call. There's a value for a function call. There's a value. Which means for the code generate and the function call. Function invocation. We actually need a value code. It is a value code, but if it's void, then we gotta do something. Function invocation. Let's hack it. Just push I. 0. So by doing this, we can always assume that it's there's a value, and then can you stop? And let's go to the call statement. So for the call statement, then we know that's a value. So let's remove value code. There's a value. So no matter what we do to pop anyway. I'm not sure. Right? This is it. This is a sign that we need to think carefully. All right. Oh, look at the change we made. There's a problem. Label not used. Okay, so we don't need it. Change that to type, semantic, visit return. Yeah, it's the part. So function definition, we add the logic to clean up the stack point and handle the return value. The function call, I always do this. Put the value over there. This is a function that we define, always handle, and call stack. Okay. And for call, we always assume there is a return, a value return, and we just pop it. And for return, we assume that it's in the function. We just get the value out on jump. For function invocation, then call it, and then load the value, save the value to stack point. Oh, no, it's not, it's load. So function invocation. Function invocation actually call the function, call into the function and do the stuff. So the virtual machine provide us the call instruction, but it didn't really handle the stack. So the calling convention is implemented by us. So we say that when we call the function invocation, after we call the function, we get the value there and calling it, calling instruction. We will fetch the value and put it on the stack. So function call turn out to be a value code. Yeah. So we have to put the value, load the value. This is a convention for the stack machine to go on operate the function result. Yeah, it's a bit. Stack point, push, subtract. And this is all the size. We clean up the size. So color cleanup, okay? Color clean up the size. Size of the argument. And wait, hold on. This one, say, if we have return value, the return value will be pointed to by the stack point. So we load the value on the machine, otherwise I load a 0. But after that, we need to clean up the stack. So we need to know the size. Oh, if it's void, then it would be 0. So this is correct. So we clean it up. For the color, clean it up. Right. I don't need this one. Okay, so now the prototype is done for function call. I still want to try like support nested function. Yeah, I'll worry about that later. Right now, I don't think we support the syntax, but that will be the next one. It's very fun. I want to try it. Oops. Thank God how long it takes.